Hi, welcome back to Chapter 7, The Strange Tale of the Phlogiston. Hi, welcome back. Chapter 7, The Strange Tale of the Phlogiston, the element that wasn't. Before we talk about the discovery of oxygen, we need to examine a very strange substance that led to the discovery of oxygen. This substance name was phlogiston, was not real. It existed only in the minds of those who believed in it, and some of the greatest chemists in the 18th century thought it was very real. We might say that these scientists got things exactly backwards. When they thought that phlogiston was added to something, the truth was that oxygen had been removed. And when they thought that phlogiston had been removed, the truth was that oxygen had been added. But they could not know that because oxygen had not yet been discovered. The very odd thing, however, is that the belief in phlogiston allowed the scientists to perform all kinds of very fruitful experiments, and we might even say that oxygen never would have been discovered if scientists had not spent so much effort in trying to understand phlogiston. Scientists, sometimes a clearly defined error is the only way to discover the truth. And here's another odd thing. The very man most often credited with the discovery of oxygen, Joseph Priestley, died believing they had actually shown once and for all that phlogiston existed and oxygen did not. He was like Christopher Columbus, who believed they had actually landed in India when he had really discovered America. But on to the story. The strange element that wasn't phlogiston began with a very strange man named John Joachim Becher. Becher was born in Speyer, Germany, and started out as a poor man who had a very rich imagination. When he was young, he was too poor to buy books, so he stole or borrowed them instead. He studied everything: theology, medicine, chemistry, politics, and law. He tried to create a universal language, one language which everyone could speak, but the man who paid him to do it rejected it. He somehow managed to convince the Dutch government that he could turn sand into gold. But the sand remained sand. He attempted to make a perpetual motion machine, a clock, which would go on forever, but he could not get the clock to start. He gained fame as an economist, even though his business ventures tended to go bankrupt. Alas, most of his schemes ended in failure. He introduced the potato into Germany to feed his pigs and cattle and hungry peasants as well. That worked. So Becker was indeed a man of many talents, but very few successes. His greatest success was the introduction of the false theory of phlogiston. Of his followers, George Ernest Schiphol, born in Aschbach, Bavaria, was a great popularizer of Becker's views. He must have done a good job. Chemists believed that phlogiston for over 100 years, and it was difficult to get them to change their minds. Some never did. What made Becker, Schiphol, Schiphol, and all the other chemists believe in phlogiston? For Becker, there were three kinds of earth, which along with air and water made up all bodies. One of the kinds of earth he named terra pinguis, of fatty earth. Schiphol named it, which he wrote in these Greek letters, for the Greek word phlogiston means burned or set on fire. Both of them thought that anything that could be burned had this mysterious element in it. Phlogiston was the principle or cause of fire. How did they prove it? Even the alchemists had known that when a metal, zinc for example, is heated red hot in the open air, a residue forms on it. As we recall from our chapter on Mr. Boyle, the metal with residue on it was called a calyx, or for example, calyx of zinc. The really interesting thing, however, was that if the metal calyx was again heated, but this time with charcoal, the metal was magically restored to its original condition. A marvelous trick, but a mysterious one. What was going on? Becker and Schiphol thought they knew. To keep with our example, when zinc was originally burned in the open air, it turned bright red. That is the phlogiston's escaping, they declared. After the phlogiston escaped, only calx of zinc was left. Zinc plus fire equals calx of zinc plus escaped phlogiston. But they also found that the process could be reversed by heating the calx of zinc with charcoal. Aha! They reasoned the charcoal must be rich in phlogiston. The charcoal must be giving its phlogiston to the calx of zinc, which had lost it. When the calx of zinc gets its phlogiston back, of course it changes right back into zinc again. So calx of zinc plus charcoal rich in phlogiston equals zinc. Now, there was a very odd thing about this equation. The calx of zinc weighed more than the zinc. As Boyle had noted with other metals, how could that be? If zinc lost phlogiston by heating, then it should weigh less than it did before. That was perplexing, indeed. How could it be explained? Boyle, we recall that the fire atoms had been added, but that answer would not work for Becher or Schittall, because they were not atomists, and furthermore, they believed that phlogiston had escaped rather than anything being added. So followers of Becher and Schittall thought that the phlogiston might actually weigh less than nothing, so that when phlogiston is added to something, it weighed less than it did before. What was actually happening? When zinc, or most any metal, is heated in air, the metal gains oxygen from the air, so the new substance zinc oxide, which they called calx of zinc, is heavier by the amount of oxygen it has gained. When it is heated again with the charcoal, the carbon in the charcoal takes the oxygen back out of the zinc oxide, and the zinc is restored into its original condition. So that what actually happened was this: zinc plus fire plus air containing oxygen equals zinc oxide, or calx of zinc. And then the process was reversed. Zinc oxide plus carbon, which is charcoal, equals zinc plus carbon dioxide. But as we said above, no one could know this until oxygen was discovered, and that required the diligent attempt to trap the phlogiston in a container so that it would be examined properly. It was by setting a trap for phlogiston that they caught oxygen instead. Hydrogen was also found. Even more interestingly, chemists found that water was made of oxygen and hydrogen, two gases. Here is the irony, however. The two men who found hydrogen and oxygen, and also found that the two combined to make water, did not believe in either hydrogen or oxygen. These men, Mr. Priestley and Mr. Cavendish, called oxygen dephlogenicated air, that is, air with the phonogenist taken out of it, and thought that hydrogen might actually be phlogiston. Perfectly marvelous errors, as we now see. Chapter 8. Mr. Priestley clears things up. Well, sort of. The first man we have already mentioned, Joseph Priestley. Priestley was born near Leeds, England. He did not start out to be a scientist, but a minister. Yet he had always studied mathematics, astronomy, and a little chemistry. It was not until he met the famous American Benjamin Franklin, while both happened to be in London, that he decided to devote himself to science, although he remained a minister all his life too. Franklin was honored in Europe for his scientific work with electricity, and Priestley was inspired by Franklin to write a history of electricity. But the more Priestley studied, the more difficult, confused, and disagreements he found among the scientists. Things only got worse as he branched out into the study of chemistry. He decided that he would have to clear things up, so it was that Priestley became a passionate scientist. While everyone in Leeds was out enjoying the fresh air, where was Mr. Priestley? At the brewery next to his house, hanging his head over a great bubbly vat of brewing beer, testing the gas given off. It extinguished a burning stick. Could it be the gas Silvestri of Helmont? Priestley had to know, but he needed to find a way to trap the gas to test it. He built his own laboratory to do just that. Now, trapping gas might seem a difficult thing to do, but Presley found an excellent way of doing it. Although it was an Anglican minister, Stephen Halley's, who invented the pneumatic trough, it was Presley who perfected it. Pneumatic trough is a fancy name for a very simple device. In fact, it was so simple that you can make one right now. All you need is a drinking glass and a soda straw, a bendable one if possible. Fill your kitchen sink with a large bowl with about 3 to 4 inches of water. Fill the drinking glass to the very brim with water. Place a piece of cardboard over the glass, holding the cardboard tightly over the glass. Quickly but carefully turn the glass upside down and submerge the rim of glass about an inch into the water in the sink. Remove the cardboard. There you have it, a pneumatic trough. That is, well, not quite. Take the drinking straw, slip it under the upside down rim into the glass without letting the rim above the surface for the water, and blow air into the upside down glass. Note that the exhaled gas displaces the water in the glass. Presley did much the same thing. He placed glass tubes filled with liquid and sometimes water, sometimes mercury, upside down in a little trough in a container filled with the same liquid. Other smaller curved tubes ran from the experimental vessel into the pneumatic trough, down into the liquid, and up into the upside down glass tube. The gas given off during chemical reactions in the vessel could then run through the tube and be trapped in the upside down container in the trough. Since the gas was lighter than the air, it rose to the top of the glass tube. This gas was Presley's began to trap all kinds of gases given off by every kind of mixture he could devise. In his most famous experiment, Presley isolated oxygen, although again he called it dephlogisticated air. Why did he call it that? Let us look at a simple example. According to the theory of the phlogians, for that is the cumbersome name we call someone who believes in phlogiston. When a candle burned, it gave off phlogiston. If a glass was put over a candle, the candle soon snuffed out. Why? Because, they said, the candle finally gave off so much phlogiston that the air in the glass could hold no more. It was saturated with phlogiston. Since the air could not hold more phlogiston, the candle could burn no longer. Now one day, we know the day, August 1st, 1774. Presley put calx of mercury underneath the glass. He focused the sun's hot rays on the calx of his new 12-inch diameter magnifying glass. It began to give off a gas. The calx of mercury changed back into mercury, and Presley trapped the gas with his pneumatic trough. And then he sat and looked, and thought, and looked some more. He happened to have a lighted candle nearby. Without really thinking about it, Presley exposed the candle to the gas, and the flames suddenly flared into brilliance. What was this wondrous gas? It gave off such light to a flame. How would it affect living creatures? Presley decided to test it with two quickly but carefully. With 2 mice. He put one mouse under one glass with ordinary air, and the other mouse in another glass with this new and magic air. The first mouse died in 15 minutes, but the second mouse lived twice that long. Mr. Presley could not resist. He had to try some for himself. He found it quite invigorating. My breath felt particularly light and easy for some time afterward, and he later recalled, so far only mice and myself have had the privilege of breathing it. He wondered if this air might be used by others for medical purposes, but he also worried about a possible danger. For a candle burns out much faster in this air than in common air, so we might live out too fast. A moralist at least may say that this air which nature has provided for us is a is as good as we deserve. But Presley had to tell the world about this wonderful dephlogisticated air. Dephlogisticated, yes. Remember, the phlogistons, a burning candle placed under a glass, continually emitted phlogistons until the air in the glass was completely saturated. So reasoned Presley, if the candle burns even more brightly than the air, must not have any phlogiston at all. It must be dephlogisticated. What really happened? He got exactly backwards. Calx of mercury is actually mercuric oxide. Just as with zinc or nearly any metal, mercury picks up oxygen when it is burned in the air. That is how the mercury oxide was produced. When Presley burned it again with the magnifying glass, the oxygen was given off and ran into the collecting tube. Oxygen allows for combustion, that is, for burning. The lit candle in the covered glass goes out because it gradually burns all of the oxygen up. When there is more oxygen present than in normal air, combustion or burning is even more vigorous. Animals also need oxygen. The mouse in the first covered glass had used up all the oxygen in ordinary air in 15 minutes. But the second mouse had a much larger supply. He had pure oxygen. Normally, air is only about 20% oxygen. So Presley got it exactly backwards. The air he thought was full of phlogiston was actually emptied of oxygen. The air he thought was entirely emptied of phlogiston was actually full of oxygen. But even though Presley was wrong about what he found, a clearly defined air, as we said above, is sometimes the only way to the truth. Before we saw how things were put right, we need to examine another clearly defined but erroneous discovery, the discovery of hydrogen. For this we must turn to another Englishman, Mr. Henry Cavendish.